For our final topic, let's turn to percentages. Talk about what percentages are and some potential problems when people reason with percentages. You should always be careful with percentages. People tend to treat them as cardinal numbers. But if you don't know the base of your percentage, or you add percentages or subtract percentages or compare percentages that have different bases, then that percentage is a useless piece of pseudo information for you. So for instance, Spuds McKinsey, our lecture mascot here, says, hey, I claim that 4 out of 5 people are heavy drinkers. But since Spud McKinsey, the poster dog for Budweiser during, I believe, the 90s, was, produced as a partying animal, right? His friends, who he surveyed, are likely to have a higher incidence of heavy drinking than people in the regular population. And these numbers aren't accidental. I'm going to show you 2 videos of Trident gum commercials and point out how this works in those Trident gum commercials.
Who wants gum?
I do.
When you chew Trident sugarless gum. 4 out of 5 dentists surveyed recommend sugarless gum for their patients who chew gum. Of America's best tasting gums, Trident is sugarless, and it comes in 4 delicious flavors. 4 out of 5 dentists surveyed recommend sugarless gum for their patients who chew gum. Trident, for families who care about their teeth. And now mints, Trident sugarless mint.
That first Trident commercial from the 70s, I realize it's pretty rough footage, but it illustrates the failure to identify and make explicit bases of percentages. So in that commercial and in other commercials around that time and going forward, Trident would make a big deal out of this percentage. 4 out of 5 dentists surveyed recommend sugarless gum for their patients who chew gum. But that selling point came under criticism precisely because the nature of the base of that percentage was unclear. 4 out of 5 dentists in the United States, in the world, employed by the Trident company, recommend sugarless gum generally, Trident specifically, a whole bunch of other gums not Trident. None of these things were clear. And so ultimately, Trident made fun of the shortcomings of their own appeal to percentages in a commercial series that started later on.
4 out of 5 dentists surveyed would recommend Trident to their patients who chew gum. But what about the 5th dentist?
Now then, would you recommend Trident for your patients who chew gum?
Yes.
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 There are many theories, but one thing's for sure. Great-tasting, sugar-free Trident helps fight cavities.
Those 2 different commercials help to illustrate how keeping track of the base of a percentage, what information it actually contains, is really important. And in fact, one of the problems that we see is that people play sleight of hand with bases, deliberately adding or subtracting them, even though they don't have the same base, treating them as if they were cardinal numbers. So for example, suppose Spuds here decides he wants to be able to spend more money on beer, but he doesn't want to increase his overall budget. And he decides that he's going to cut his food bill by 10% so that he can increase his beer expenditures by 10%. Now he's taking those 2 percentages as though they pick out the same amount. But if Spuds already spends less on food than he spends on beer, then cutting his food bill, say he spends $100 on food, by 10%, that will save him $10. But increasing his beer expenditures, let's say he spends $200 on beer by 10%, will mean that he'll be spending $20 while only cutting $10, and hence will increase his spending by a net $10 because he doesn't take the base of the percentages into account and adds percentages with different bases. I'll end the lecture by talking about one last difficulty that people have when reasoning with percentages. Another way that people oftentimes mistakenly reason based upon percentages is to take the percentage as determining an outcome without considering the effect of the frequency in the population or the base rate. Now, we talked about that when we talked about Bayes' theorem. We saw that relatively infrequent events can oftentimes get you a positive test, but the false positive test is very high. So, for instance, we talked about how incidence of schizophrenia in the population is 1 in 10,000. If we had a 98% accurate test that would determine whether or not you develop schizophrenia, say within 2 years, and people take that test, 10,000 of them, one of them will get a correct positive. They will show that they are in fact going to develop schizophrenia out of that 10,000. But for every group of 100, we're going to get 2 positive tests suggesting that they will develop schizophrenia. Now that's 100 groups of 100. And that means we will get 200, well really 199 false positives and 1 correct positive every time we get to 10,000 people. So taking the base rate into account and using Bayes' theorem, again, is non-intuitive, but it's very important when we make inferences using percentages to make inferences about populations.